Okay, so what I was saying is the video cut out there is that this equation might seem awful at first, but after you write it down for each question, there are terms that are going to cancel out, and you're going to be left with something easy and more manageable, okay, like this little guy. So let's try a second example. It says, it should say you throw a ball, make that not a capital, you throw a ball into the air with a velocity of 15 meters per second. How far above your hand will it rise? So the ball starts down here and it goes up, and of course it's going to go up until it stops. Okay, so we could do this with kinematics, and we have, but this time in this unit I want you to do it with energy. So kinetic energy, 1/2 mv initial squared plus mgh initial, your gravitational potential, plus 1/2 kx initial squared, your elastic, should be equal to 1/2 mv final squared, mgh final, 1/2 kx final squared, plus E loss. So now in these first ones that we're doing, so there will be no E loss today or tomorrow. And in all of the ones from today, no spring, okay? I'll get to spring in the next set of examples, springs. So down here at the bottom, you give it a speed of 15 meters per second. So initially, does it have a speed? Yeah, 15 meters per second. Down here at the bottom, does it have a height? No, because that's, it's saying for how high above your hand. So the initial height is your hand, that's 0. It's going to reach this highest point up here. It's going to go up until it stops. So it doesn't have a speed at the top, and we're asking how high above your hand did it rise. You're looking for HF. So you're left then with 1/2 mv initial squared equals mghf. The masses are the same. It's the ball. They cancel. This time we're solving for HF, so divide both sides by g. So 1/2 v initial squared divided by g. 1/2, v was 15 meters per second. You're going to square that, and then you're going to divide by 9.81 meters per second squared. 225, 112.5 divided by 9.81, 11.468 meters. And you're done. Okay? So in both these cases, the kinetic at the top will be equal, gravitational potential at the top will be equal to the kinetic at the bottom, like the kid on the slide that we did there earlier, except there was E loss there. All right, one more example. A 4-kilogram ball is attached to a 5-meter long rope, forming a pendulum. Okay, so it's hanging straight down here, like this, at its lowest point. And then it says the pendulum is pulled back to an angle of 36.87 degrees. So we pull it back here. And here's my theta, 36.87. And it wants to know what speed will it have as it passes through its lowest point. So when it's pulled back here, it has some height, and I'm going to call this my height initial. Okay, and its speed initial is 0 because I'm holding it. But when I let it go, it's going to swing down here, and it's going to get to its lowest point where its height final is 0. And it's asking you, what's its speed down here? And before it starts to swing up on this side. So this will actually be its spot of maximum speed. So it looks like we have two unknowns, but we really don't. And we don't because we were given the angle. So if you draw a line straight across from your pendulum bob at its highest point so that it makes a right angle here, we know that this side is 5 meters, and we know our angle is 36.87. So we could find this length. It's the adjacent side of this right angle triangle. So we could do cosine of 36.87 is equal to my y over 5 meters. So my y is 5 meters times the cos of 36.87. Cos of 36.87 is 0.8 times 5. My y is 4 meters. Okay? Now, how does that help me? Well, I know the whole length of my pendulum is 5 meters. And so if this is 4 meters, then this little piece, which is my HI, must be 1 meter, because HI will just equal the length minus Y. So my height initial is 1 meter. Now that I have that, now I can go to my energy. So 1/2 mv initial squared plus mg h initial plus 1/2 k x initial squared is equal to 1/2 mv final squared mg h final 1/2 k x final squared plus E lost. And before you whine about writing it out will just cement it in your head, so it's not a bad thing. We will be using the same equation in grade 12, so it's not a bad thing to get it cemented in your head. Again, no E lost. So if this is my initially when I'm holding it up here, when I've brought it up before I let it go, it doesn't have a speed. It does have a height. There's no spring in this question. At its lowest point, it has a speed, but it doesn't have a height, and there's no spring in this question. So I have mgh initial equals 1/2 mv final squared. Again, the m's cancel, and this time I'm looking for v final, so multiply both sides by 2. 2ghi, 2 times 9.81 meters per second squared times 1 meter. Remember, that's going to be vf squared, and you get 19.62 meters squared per second squared, and then take the square root and get 4.429 meters per second. Okay, so your ones to work on here will be similar to these. Okay, and then the next day we'll introduce springs into them. Very good.